Hey guys, what's up? Eddie Aho here with KissAnalog.com and two 48 volt 5 amp power supplies. Yes, they're both the same voltage and current. This one is a GaN FET technology. You know, it's the newer type of FETs. Okay, so it's not a MOSFET, it's GaN FET. And this one doesn't say anything, so we're just assuming it's MOSFET. GaN FET switch faster, more efficient. I can do another video to talk about that. I've done some videos in the past. GaN FET, the new technology for power, something to that effect. But anyway, yeah, so we're gonna test these two. I just did a video showing this guy will put out 5.7 amps for a continuous amount of time, doesn't overheat, and seems to be pretty clean power. This guy, I've never really put it on a load bank. I have a load bank up here. I'm going to put it on, and we're going to try to pull out 5.7 amps out of this too, I think. And I've got an AC power source here. Both of these are iTech devices. This guy up here is an 8512A. It's an IT 8512A Plus. Very nice active load, electronic load. This is the IT 7321 300 VA AC power source. So I'm going to use that, because I could plug it into the wall strip, but this gives me some protection. Plus it gives nice clean power. And we want to compare these, not how clean my house power is versus these and that kind of stuff. Like how much house power is going through versus, you know. So we're kind of standardizing the test by using that. All right. My house power might be cleaner than yours or vice versa. In the US, they're all going to be pretty good. 120 volts, 60 hertz. So, all right, guys. So you saw this one before. We're going to use the Uni-T, the MSO 3054 HD scope. Super nice scope. We're going to look at the spectrum, the FFT of both of these. And we're going to compare them to see, first of all, can this do the power? Second of all, you know, we already know this one can. But also, is there noticeable, you know, ripple difference, voltage ripple? Are they both going to be clean? The FFT going to look good? The FFT shows the amplitude of each frequency. So it should show the switching frequency, harmonics, show that how much amplitude each one of those frequencies. It's like a spectrum analyzer. Okay? All right, guys, let's jump in this, check it out. Hey guys, just real quick, hit the like button, subscribe if you haven't done so yet. Really appreciate that. Trying to grow the channel, and hopefully you like these videos on these power supplies for these Class D amplifiers. This one, by the way, came with the Aiyima A70, the GaN FET one, and this guy came with the Fosies. And I've got different Fosies. This is a ZA3 that I'm going to do a review on, and I think I just did the one on the V3 mono. Okay, so yeah, I think I did that one, didn't I? Anyway, got a bunch of amps I got to do some testing on, but I want to look at the power supplies, you know, see what they look like. All right, so let's jump in the video. Like the video if you don't mind. If you like it, get something out of it, subscribe. If you think you're subscribed, check. I've had a few people tell me that YouTube's unsubscribing people for some reason, so that might explain why growth has been so. My views go up, my growth is not going up. So it's like they're showing, like, you know, 80% of viewers are not subscribers. All right, let's jump into the video. Thanks, guys. Okay, guys, this is the GaN power supply that we're testing first, okay? And this is the non-GaN. All right, so you can see the size difference. So let's go ahead and test this. Now the output comes over here. I have it jumpered into this, and these leads right here go to my load. Okay, this is a scope where I'm taking the measurements right here. Then I have these leads kind of jumping around to the KPS meter. All right, so we're reading the voltage right here. All right, guys, and here is the nice Uni-T MSO 3054 HD. Okay, so I've got that set up. You can kind of see it. I'll come back and show you that a little closer. So this comes up here right now. We're at 0.6 amps, so not very much power. All right, guys, right now we're 0.6 amps, 48.4, okay? So just slightly less than the meter. And down here, we have our AC power supply set up 119 volts going into it. And we got 32 watts. And the power factor is 0.96 of this low power, okay? 0.28 amps, 60 hertz, all right? So now let's go look at the scope a little closer. All right, so hopefully we're getting a good view right there. Now, here's a rip over on this screen, okay? I can do another video showing you how I set this up if you're interested, but right now we're just using it as a tool to show you some measurements. Here's a FFT. Now, this is up to 500K, from essentially 0 to 500K, okay? So we got 250 right here in the middle. And the switching frequency is this guy right here. Here, let me freeze it. Okay, it's about, well, it says about 191. It kind of bounces around. It's probably around closer to 180, I think is what it is, 178. So we're kind of bouncing around. It's catching the harmonics. But if you, this is minus 52 right here. Okay. Now there is one right here. Here, let me go to a little higher frequency so we can see. Now start. You know what? Let me set this up. It kind of moved, but let me go back to 0, okay? So 0, enter for that. And then now it's 500K. But let's go to 1 meg. 1 meg. Okay, get rid of that. By the way, it's really awesome that you can move these windows around. That's something I've always liked or wanted in a scope. So they're just not stuck where they are programmed to go. Anyway, so this is 1 meg. You see after 500K, they drop off. That's why I kind of stopped at a 500K. Okay, so you can see all these other ones. They're way down here. Here's minus 72, minus 52. So minus 62 is in the middle. Okay, so that's in the middle. Now, this position here, let me set this position to an even number. So that'll help solve that problem. Okay, so there's minus 50, minus 70. So you can kind of see where the numbers are, right? All right, so anyway, I've got these, I got 6 different markers, and like 4 of them are, and it's set for, I think it's set for minus 60. Hold on a sec. So yeah, minus 60. So anything above minus 60, it's going to mark. And I got 6 of them set up. Okay. You can see this is a super nice scope. But anyway, so there's what we're seeing. Okay. So minus 47 is the number 1. This guy right here, around 500. That's probably the, you know, several harmonics from the switching frequency. I'll go back to here, and I'll go back to, say, 500K, just so we can zero in a little bit closer to the bigger spikes. Okay, so now we're 0, 250, 500K. Minus 50 is right here. So you can see that one that we were looking at before, right around 500, is the tallest one, okay? And up here it's showing it 400K is minus 46. So here, if I freeze it for a moment, we got a minus 46, 53, 55. Well, it's almost 56, 58, almost 59, another 59. So yeah, you can see that. So they're all very low, right? 1 volt or 0 dB would be 1 volt. Minus 20 would be 100 millivolts. And minus 40 is 10 millivolts. And minus 60 is 1 millivolt. So we're talking about 1 millivolt readings through here. Okay, so that's very, very small ripple that we're seeing over here. The switching frequency, it's just very small. If you saw my last video where I showed this amplifier, showed the ripple and the power. Okay, now this is 0.6, right? Now watch this as I increase the load. Okay, I'm going to increase the load up to 1.6. Now you see this bounce of it just because, but then it settles in and you'll see about the same as what it was. And same kind of numbers. We're not seeing much. Added an amp, so we're at 82 watts now. Okay, I'm going to go to, there's 2.6. I'm going to make this a nice even 3. Okay, there's 3. Okay, there's a nice even 3 amps. Okay, we are at 154 watts into the power supply. So minus 41. So it's gone up a few dBs, maybe just a few, but still very low. Now let's go to the max 5 amps. Okay, guys, that's the maximum 5 amps. Okay. And by the way, if you notice this FFT, just for funds, okay, if you notice the FFT points, I got 4 mega points. That's crazy. That's a lot of mega points. Okay, so that's the setup. If you can read that, hopefully you can. And there we go. So I'm going to freeze that and save it. And now you can see the ripple once I stopped it. All right, so we're going to save that. And here, let me just show you the power or the voltage. 4766. Okay. We're going to come up here, 47.4. So we're dropping 0.2 volts across the leads. Okay, 5 amps. And we come down here, 257 watts. And power factor is 0.996. Pretty darn good. Right? Pretty impressive. Okay, I'm going to save that. Storage. It's PNG. That's fine, I guess. Maybe I'll save as a JPEG this time. Color. We got all these things we can set up. I'm just going to go ahead and let it default set up. Just going to save it locally, internally, because I don't have a SD card plugged in or just, a little thumbstick. So there we go. And by the way, 170 kilohertz switching frequency. Yeah, that's what I was thinking. It should be around 170K. Okay, and that's going to be right here. Then right next to is 171K. Both of those are like minus 39 dB. Those two spots right there. Okay, so then 173 is number 3, and so I think all 3 of those are right here, and that's minus 43. Okay, then we go to 4th one, and that's at 400, so that's over here. And that's a minus 52. And then 5 is minus 53.4 rounded off. And 6 is minus 55.4. Okay, so there we go. Pretty solid. I mean, that's a max power, okay? 257 watts. All right, guys, so I unplugged the GaN, and now we have the regular MOSFET-driven power supply. And all I had to do is unplug right here and plug it in, so I didn't have to touch anything. And then over here, I just had to plug this in. They take the same type of plug for both of them, so that's really handy. And I haven't turned it on yet. All right, guys, I have a 0 load set up. All right, so let's come down here and it's set for 120 volts, 60 hertz. Let's turn it on, the output. Okay, it jumped up, it's charged up the output caps, all that kind of stuff. So now it's just kind of bouncing around as it charges up cap, turns off. So it's in this kind of mode. So let's just come over here and we'll go half an amp, okay, or 0.3 amps or something like that. Okay, so just a very small load, 17 watts. So starts off 17 watts, 0.91. That's very good. So it seems like this has a power factor correction circuit on the front of it too, because that's very good. Now we're at 39s, 43s, 52s on this one, max power. So let's go ahead and turn it on. Let's catch the waveforms again. Okay, now we got a few different ones over here. This guy, I think, switching a little lower frequencies because we don't see much over here on the high stuff. So the GaN, the reason it's a smaller power supply is it's going to switch faster. This guy is probably switching a lot lower frequency. This 250 is going to be, in the hundreds of kilohertz it's probably switching. okay, like around 100 kilohertz maybe. So we could tell by looking at the ripple over here. Here, I'll freeze it. And okay, let's move the cursors. So kind of the second bump. One's probably a turn on, one's turn off, and that's a duty cycle maybe. So right over here, we have about 33K. Now that's really low. So yeah, I have a hard time believing that's switching frequency. Now the thing is this could be a resonant mode where with very low power, it goes into this pulse skipping or this low frequency. So let's go ahead and bring in the power and see what happens. Okay, so I'm gonna turn it back on, turn the triggering on. Okay, and just did it right over here in the corner in case you missed that. So, all right, so I just try to show that scope. All right, so let's go ahead and bring up the load. Okay, now I haven't tested this one actually at full power yet, so we will hope that it can do 5 amps just fine. We will find out. Okay, right now things are looking pretty good. Okay, we saw a spike pop up here, 166K, 163K, and we see some higher frequency ones. So now we're seeing all that. Now look, well, you know what? We'll keep zoomed in, and then we'll go look at the 1 megahertz once we're up there. Okay, that's 1 amp. Okay, now we're at 5 amps. Okay, you can see the ripple looks a little bit different than the other one. Okay, now let's come over here, 47.59. Okay. Okay, up here we have 47.3. So we're again a couple tenths of a volt, which is, you know, that should be expected, the same as last time, same current, 5 amps. Okay, come down here, we're at 259 watts, 0.99. So yeah, very good power factor correction in this one as well. That's awesome. So with very good power factor, you should have low noise. And right now we're seeing a lot of low numbers. So that ripple looks pretty constant over there. Let's stop it. And I'll go back over here. And I could probably, I can move those cursors with my finger, but it's a lot easier when I'm trying to get them close like that. So 206 kilohertz. So it's probably a 200. Yeah, it's probably 200 kilohertz switching. Okay. Now you see it kind of go up and then down and then up and then down and then up and then down. That is low frequency ripple. Not sure if that's due to the power factor correction circuit. So the input capacitor or the output capacitors, but it's no big deal. It's very little. This is 50 millivolts per division. So, yeah, it's very, it's very small ripple right there. So, and over here, you can see that minus 36.6, minus 39, and then minus 45, minus 47. So, you know, it's kind of similar results. I mean, we're seeing there's all this activity down here is between, well, minus 60 and minus 70, so very low. Now here, let's get it running again, okay? And we're gonna go out to 1 megahertz just so you can see that as well. Let's try that again. Okay, let's try this 1 meg. Okay, cool. There we go. And same kind of thing. Here's 500K. You know, it seems like out around 300K, you know, it seems like it's lower out here, and most of the activity is around up to the first couple hundred kilohertz. So if anything, what do you guys think? This might look a little bit better than the GaN, right? A little bit lower spikes, but I mean, still, they're both so low. They're both looking so good. I'm going to freeze this and save it. And you can kind of see what I'm talking about. Low frequency ripple. We get spike, spike, spike. It kind of grows and then it drops and it kind of so you can kind of see that pattern. That's a kind of a lower frequency ripple. And just for fun, since we're here, let's see what that is. Okay, this is kind of where it builds up. Well, here, I'll get that spike right there where it kind of builds up. And then let's see. So it kind of builds up and then drops off. So that is about 32 kilohertz. Yeah, that's a little bit lower frequency. And then I was trying to pick out some more clean spikes. See, there's a double spike, kind of a double, kind of a double. So let me grab this bottom one. Well, I'll grab this bottom one right here, and then I'll grab that bottom one. So if you see what I'm talking about, it's kind of a double spike, double spike, double spike, double. So I'm trying to get two double spikes next to each other so we can get a better thing. That's about 40.6 kilohertz. So otherwise known as 24.64 microseconds in between. So yeah, that's kind of what we call, you know, what I've referred to as a low frequency. And then we have the high frequency pulses in between, which this guy, the biggest spike is 164K. I think this is a resonant converter because the frequency seems to shift around as we change the load. So there we go. They both look very good. And by the way, it's still 5 amps. My hand's been resting on it, and it's still very cool. You know, it might run even a little bit cooler than the GaN just because it's so large probably, but we've only been here a few minutes, so I think I'm gonna turn off the recording and come back in a few minutes and see how warm this gets. But right now, looks like it's doing great. You know what, guys? The last video I did, I took it up to 5.7 amps, the GaN. So let me do that with this guy. And the reason I went to there is because I'm just look at that, 296 watts, because this is good for 300 VA. So if we have a power factor, and look at this, power factor is getting close to 1. So that the VA and the watts are almost equal. Well, they are equal because power factor is 1. So again, another very nice power factor correction circuit in here. Ah, it's almost cold. I feel there's a little bit of warmth on this end. I mean, it's barely though. So yeah, I feel like this guy's actually running cooler than the GaN one did. But again, we gotta let it run for a while. And you know what, let's turn this on just to see. Okay, we didn't see really anything change much at 5.7 amps. So guys, it's ready for 5 amps and we're getting 5.7. Very nice. And by the way, you're probably loving this scope, right? I can show you how I set this up in another video, just so we don't make this one too long. Let me know if you like that. Get the comments and likes in the video, please. By the way, I just want to show you something. I pulled up the storage again, and you know, just went to this thing and went to storage, and it was nice. It kept my settings from last time, so I love that. So save that. It's nice. It's got built-in memory, so I don't have, if I didn't have a card, you know, I can erase it later, but for now I can start filling up memory. But yeah, just a quick one. I mean, we got our FFT right here. That's what this window is. I could have made it take over the whole thing, but I'm sharing with that so you can see the ripple. And here's generator math, references. I don't know if you can read that in this, you know, but anyway, but here's a Bodhi plot. So a lot of cool stuff. All right, guys, you know what? They both do 5.7 amps. This actually, the big one, the MOSFET one actually runs cooler than this guy. But this one gets warm, toasty, but not too hot that you can't hold on to it. You know, you can, you know, you can hold on to it and it's just a nice toasty little brick. This guy actually stays a little bit cooler. Stays pretty cool actually. So, yeah, I mean, it warms up, but yeah, anyway, there you go. 5.7 amps on both. As far as the spectrum, the noise, the ripple, that kind of thing, they look comparable. They're different, but similar at the same time. The amplitudes on the MOSFET one seem like they're more around 300 kilohertz to lower frequencies, where this guy, the highest one is around 400, 500 kilohertz. You know, there's one spike that's jumping around there, one of the harmonics of the switching frequency. So they're both, it's very high frequency. They're both very low. the power factor on both of them was very good, meaning that if you're getting your VAN 300, say VAN, and 300, and that's actually watts, then you're not losing much, if anything. You know, you're losing very little in noise, and the current and the voltage are actually in phase, so that's great. But it's not just about current and voltage being in phase, it's also the noise. If you have a lot of noise that turns into energy that's lost, that's also factors into your power factor. So all right guys, so there you go. What do you think? Let me know in the comments below what you guys think. But the little guy runs a little bit warmer, but they both put out power and they both look relatively clean, right? I mean, that's clean power. So all right guys, thanks for watching. 2 big thumbs up to my patrons and my YouTube members, and Danny being a team member, appreciate that. You can join down below for as little as $1 a month, and yeah, I appreciate that guys. There's a super thank you button down there too. So yeah, I kind of pop up here to show the guys that have hit it in the last month. So all right guys, thanks for watching, and we'll see you next time.